Hey everyone, we're going to solve this equality. X squared is less than or equal to 2x plus 2. You know what I'm going to do? I'm going to take it and I'm going to write instead x squared minus 2x minus 2, right? I'm going to take and move these over to the other side. And that's going to be less than or equal to 0. So now this looks a lot like standard form, or general form, right? And I can't factor it, so I'm going to use the quadratic formula to find our roots. It means that x is going to be equal to a negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 2, and then all of this is going to be divided by 2 times 1. So let's start simplifying. We'll get 2 plus or minus the square root of 4 plus 8, and this is divided by 2. So this is 2 plus or minus the square root of 12 over 2, which is, let's see here, 2 plus or minus 2 square roots of 3, right? 12 is equal to what? 4 times 3, so this is the square root of 4 times the square root of 3, which is 2 square roots of 3. So what does x end up being? X ends up being 1 plus or minus the square root of 3, right? We divide everything by 2. This divides by 2, that divides by 2. We get 1 plus or minus the square root of 3, which we could probably use some help figuring out, I think. I don't know it off the top of my head. Let's take a look at the number line, right? Because what we do is we find our zeros, then we test points. Let's see what's going on here. Well, I know this is going to be 1 plus the square root of 3, and I know that over here this is going to be 1 minus the square root of 3. But do I really need to break out the calculator and figure out exactly what these are? I'm thinking no. I'm thinking no, I don't. I'm thinking I don't need to actually break out a calculator to figure out where these zeros are. Because the square root of 3, this is going to be less than 1 plus or minus the square root of 4, right? So that means over here sits 1 plus 2, 3, and over here sits 1 minus 2, negative 1, and in between them sits 0. So I can make an approximation and then pick some points that are far enough away from that approximation and use those. Awesome. So let's take a look over here. This is going to be negative 1 squared is less than or equal to negative 2 plus 2. 1 is less than or equal to 0. Well, that's false. Alright. Let's go over here. 3 squared is less than or equal to 6 plus 2. 9 is less than or equal to 8. Hey, that's false too. Alright. So it looks like we've gotten the false stuff out of the way. Let's hope here 0 squared is less than or equal to 0 plus 2. 0 is less than or equal to 2. Hey, that's correct. And since this is less than or equal to, that's going to influence our solution and give us hard brackets, right? So this is going to be 1 minus the square root of 3, comma 1 plus the square root of 3. That's where our solution is. So we had to do a little bit of solving, get everything into, write it out nicely here, general form. Get everything into general form. Then use the quadratic formula, test points, and interpret. And finally, we write that solution as an interval. And that's how we solve a polynomial inequality. One other thing though, we could be solving them graphically. So I'm going to call up my graphing calculator here, and I'm going to do, I'm actually going to do x squared minus 2x minus 2. And let's just do a little zoom standard. Let's do zoom standard. Let's take a look at that now. See, here we go. So we can see where these points are. I could call up the table, second table here, and look over for y equals 0. So it's somewhere in between these two. I can see still don't know why it does that. I guess if you start tapping a whole bunch, it does silly things. Or what I could do is I could do x squared, so x squared, and then for my next graph, do 2x plus 2, and then do these at the same time, zoom standard here. There's x squared, and there's 2x plus 2, right? And I'm going to zoom in. I'm going to zoom in and center it right about here. Alright. So we can see where they overlap. It's too soon. Well, I'm still just going to trace it. Over here, where they overlap is where it goes from x squared being greater than to x squared being less than. So right here is the x squared is less than region. Oops, pardon me. I guess I just can't keep tapping at this thing. And we can see that region. And if we had a different graphing tool, like Desmos, we could absolutely do x squared and 2x plus 2. Call that up and take a look here. Zoom out, find these points. Desmos is very good with this. It'll find that point, it'll find this point, and those are our 2 points where we change from less than to greater than, right? First point, second point. That's where we switch over from less than to greater than at those 2 points. What it's not doing for us is giving us those exact values, which are the values from the with the square roots in them, like the 1 minus the square root of 3, 1 plus the square root of 3. So we're still using algebra, we're using the quadratic formula to find the exact roots. But a tool like this can do a very good job of finding the approximate roots. The calculator could probably, if we tried, find the exact roots too. So either one of those are good tools to let us know, yeah, we're moving in the right direction, no, we're not. Or for the calculator, we could even quit out of this and look at 1 minus the square root of 3 and get negative 7.32, whatever, and use that as a check and say, oh look, that's the check, that's cool, that's the data that we got right here. Excellent. I will see you next time.